Hello everyone, welcome to Learn Data Structures and Algorithm in Python course. In today's lecture, we'll be solving a linked list problem on Leetcode. So you will be given a linked list and you will be given a head of the linked list. You have to remove nth node from the end of the list and you have to return the head. What does it mean? Let's say you are given a linked list. Let's say the nodes are 1, 2, 3, 4, and 5. Then you have to remove node 2 from the end. Means if you take this linked list, so from end this will be our first node, 5 will be our first node. Then from last in second position 4 will be there, right? So what you have to do, you have to remove only this node, this 4. Then how the linked list will be look like? It will be look like 1, 2, 3. Then 4 will be removed, then this 3 will be pointing to 5. So this is our problem, right? So let's say in your linked list there is only one node, one, right? And you have to remove the node from the last, first node from the last. Then what will be the output? So there are only one node, right? So from last it is only the first node. That's why you have to remove this, and ultimately the linked list will be empty. Let's take this example 1, 2, right? So node 1 and node 2. Then if you remove the first element from the end, so that means we have to remove 2 here, right? So their own one will be present here. Now how we can solve this problem? Let's see. So let's say there is 1, 2, 3, 4, 5. Okay, so 1, then it is pointing to 2. Okay, then it is pointing to 3, right? Then it is pointing to 4, and then it is pointing to 5. So this is our linked list, right? So this is basically the head node. This is head. Okay, head of the linked list. Now there is an integer n equals to 2 given. That means you have to remove second node from the end. Second node from the end. That means this node. Now how we can do that? So just think about this. So brute force approach could be, let's say, first we get the length of the linked list. First, let's say we get the length of the linked list. Okay, let's say the length is 5. Okay, then we know that second node we have to remove, right? Second node we have to remove. Now tell me, if we want to remove the second node from the last, that means this pointer, the next pointer of this node, the previous to this, should be pointing to whatever node we want to remove, those next, right? That means what we have to do, we have to just refer the next node of 3 to 5. But how to do this? And how to choose which node should we take? How to choose? That is simple. So if you got the length of the linked list, then if you minus whatever length, whatever, so that means n. So whatever node you want to remove from the last, if you subtract that, that will be our node where we can do the operation, from where we can do the operation. So but the challenge here is that how we can get the length of a linked list, how we can do that. The simple approach could be, we have to traverse from each node, traverse through each node, traverse through each node. And when we traverse, we'll take a count variable, initialized with 0. Then whenever we traverse node 1, node 2, node 3, up to null, right? Up to null or none. Then what we'll do? We'll increment the count by 1. That is our funda, right? So we'll be traversing through each node and we'll increment our count. Then we can get the length, right? Then we'll get the length. So let's say length is 5. Okay. Then what we'll do? We'll subtract length minus whatever n is given, right? Then what we'll do? Whatever we get. So let's say, let's take a variable called difference. Okay, let's calculate as difference. So difference equals to length minus whatever node we want to remove from the last. So let's say length minus 8. Okay, so now we got the difference. So here difference would be 5 minus 2 equals to 3, right? Okay, then what we'll do in the next step, again we'll be starting from the first, right? Then we'll traverse the node one by one. So first we'll be going here. Okay, then what we'll do, we'll traverse again. Then what we'll do, we'll traverse again. How many times we have to jump? How many times we have to jump? That is basically the number, the difference, whatever the difference, that many times we have to jump, right? So how we can do that? So let's say first difference is 3, right? So let's say I first go to the first node. Then what I'll do, I'll decrement the difference. Okay, so difference will be 2 now. Now when he traverse to next node, when he go to next node, then again decrement it. Okay, so 2 become 1. Then again when he traverse to next node, we'll decrement this, so it will become 0. That means how we can traverse? So once we get the difference, so what we'll do, so we have to do like this. While difference greater than 0, while difference greater than 0, then what we have to do, so let's take a current pointer. Okay, so current, we have to do current equals to current dot next. That is typical process, right? And we have to decrement the difference, so difference minus equals to 1. That will be the process. Okay, I hope now you have understood. So once we get there, what is the next step? So let's say this is our target element, right? So what we have to do, when we are at this node, so next pointer of this node should be dot next. That means 3 dot next will make 3 dot next. That means we are just pointing 3 dot next to 3 dot next. So that is the process. This is the whole code, right? Now here is one problem is there. Let's say our linked list has only one node. Okay, let's say one node, means that is basically head. Okay, now we have to remove the first element from the end, right? We have to remove first element from the last, so n equals to 1. That means we have to remove this element. But here problem is that, so there are no reference node, right, where you can sit and do the operation. So here 3 is the, so here you can see 3 is our reference node, right? 3 is our reference node where you can sit and do the operation. We can do the operation. But when there is single node, so there is no reference point, right? So there is no reference point. That's why what we'll do, we'll create a dummy node. Let's say we'll create a dummy node. So this is basically a dummy node. Okay, then what we'll do, we'll we'll point this dummy dot next to head node. And make it this as result. That is resulted node. Then what will happen, let's say I want to remove this element, right? I want to remove this element. Then what we'll do, this dummy node will be my reference point where I can sit and do the operation. That means from there I can point this dummy dot next to none, right? We need a reference point. That's why we'll take a dummy node, right? So this is the only change we have to do. Now let's see how we can write the code for this. So first what we'll do, we have to count the length of this linked list, right? So how to do that, how we can count the length of this linked list? So let's take a variable, let's say take count as 0. Okay, then let's take a node current, so and it will be equals to first pointed to head, then while current, what we'll do, make current equals to current dot next, right? And we'll increment the count plus equals to 1. Okay, that is done. So now we got the count. So what is the next thing, we have to calculate the difference. What is the difference? So difference would be basically count minus n, right? Count minus n. Then what is the next thing, we have to take a dummy node. We have to consider a dummy node. So let's create a dummy node. Okay, dummy equals to, let's create a new list node. Okay, list node, and it will be, you can put anything here. I'm putting -1 here. So now point this dummy dot next to head. head of our linked list. And let's take a resultant. So that will be basically dummy itself. Why we are taking this resultant node? Because when we traverse to each element, so dummy will be our last element, right? So we'll not get the reference of this node again. That's why we are taking another variable resultant that will refer to the dummy node itself. So it will basically remember this. Now what we'll do, so now we got the difference. Now what we'll do, while difference greater than 0, do what, make change this dummy node. So dummy will be pointing to dummy dot next. Okay, and we'll decrement the difference minus equals to 1. That is done. Then what is the next thing? So now we got the reference node. So here we'll do dummy dot next equals to dummy dot next. Okay, right? Now this is done. Then what is the next thing? So what I mean by that, let's say we calculate, so this is our node, right? 1, then this is 2, then this is 3, then this is 4, then this is 5. Okay, this is 5. Now this was our head. Okay, now we have created a dummy node here, -1. So this is basically a dummy, and this is actually resultant node. Okay, so now let's point dummy dot next to head node. Okay, now what we'll do, we'll get the difference. So difference equals to, here is 3, right? So what we'll do, we'll traverse this dummy node one by one. So that means first time difference is 3, we'll move this dummy from here to here, right? Here to here. Then difference will be 2, right? Difference will be 2. Then what we'll do, again we'll move our dummy pointer to from here to here, dummy, because dummy equals to dummy dot next. Then so we'll decrement the difference again, so difference will be 1. Now what is next? Again we'll move our dummy from here to here. Okay, dummy from here to here. So now, and decrement the difference, so difference becomes 0. That means we'll not go further. So from here what we'll do, so this is dummy, right? So dummy dot next, we make it as dummy dot next. That means this link will be lost, right? So dummy dot next will be dummy dot next. So dummy, currently dummy is this, right? So dummy has changed to here, right? Dummy has changed to here. Now how we can get the reference of this node here? That's why we have take the another pointer as result, right? Res. So that's what we have written here, result equals to dummy. So that has the reference of the initial, the dummy node. So now what we'll do, we have to return the head of the linked list, right? This node. That means we have to return res dot next. So what will return? We'll return res dot next here. So that will be our answer. Let's run it. Okay, it is accepted. Now let's submit this. Yeah, it is accepted. So I hope you have understood the problem.